Let us now study about accumulation of a radioactive element in a radioactive series. We already studied that if a radioactive element E1 decays to a daughter nuclei A2 with a decay constant lambda 1, and if A2 is also radioactive, it will further decay with a decay constant lambda 2 to another element A3, and so on. The process continues. And this series of radioactive elements we call a radioactive series. Now in this situation, let at t equal to 0 there were n0 nuclei of E1 were present and no other element were there in the initial instant. And if we talk at time t, and after time t, say number of nuclei of A1 are n1, that of A2 are n2, and that of A3 are n3, and so on. Now in this situation here we can state A1 is continuously decaying so that A2 is being produced, A2 is decaying so that A3 is being produced. Now in this situation A2 will have a formation by disintegration of A1 and it will decay to A3, so A3 will be produced by disintegration of A2. So about the element A2 we can write number of nuclei of A2 would be changing because from one side it is being produced and the other side it is being disintegrated. So here we can write at time t, if dn2 nuclei of A2 are accumulated in time dt, this implies here we can write dn2 will be the number of nuclei of A2 which are accumulated in time dt. So in time dt, number of A2 which are produced can be written as lambda 1 n1 dt, because lambda 1 n1 is the activity of A1, the rate at which A2 is being produced per unit time. So multiplied by dt is number of these are the number of atoms or nuclei of A2 which are produced in time dt, minus number of nuclei A2 which are disintegrated to A3 will be lambda 2 n2 dt. So in this situation we are getting dn2 by dt is equals to lambda 1 n1 minus lambda 2 n2. This is giving us the rate of accumulation of element A2, this rate of accumulation of A2. Now in this situation after time t, n1 we can directly write by decay as n0 e to power minus lambda 1 t, as A1 is not being produced, it is only decaying. So this equation can be rearranged as dn2 by dt plus we take this term on the left hand side, it will be lambda 2 n2 is equals to lambda 1 n1 we can write n0 e to power minus lambda 1 t. Here you can see this is a linear differential equation of form dy by dx plus py is equals to q, where p and q are functions of x. Now I hope you might have already covered the topic of differential equation in your mathematics calculus. So here I am leaving it as an exercise for you to solve this equation, and we can directly write after solution or after solving this equation we get the final result of number of atoms or nuclei of A2 which are accumulated in time t. This is given as lambda 1 n0 divided by lambda 1 minus lambda 2 multiplied by e to power minus lambda 2t minus e to power minus lambda 1t. So I am leaving this result as an exercise for you to derive from this equation, and for this you must know how to handle a linear differential equation of this form.